James, hey, it's Jeff Carr here. Really enjoyed reading your post. I don't think that I have had much interaction with you this semester or any other semesters perhaps. There's a lot of students in our classes, but I was really glad to read your post. And I really liked just how succinct you made everything. It made it very easy to understand, and it made it very easy for me to follow along with, because these are some very complex what are the word I'm looking for? Very complex topics, complex terms that we're dealing with. And when we're talking about data, it's really important that all of the stars kind of align. And we know that doesn't always happen when we're doing research, but we want to make sure that we can account for all of those things that aren't aligning. For example, I like that you talked about how in any project you have to have the right materials for the right job. And having the right materials will equal a finished and accurate job. And in the same way, if you're building a house, if you are building a shed, if you're making a cake, if you're making a pizza, whatever you're doing, you have to have the right ingredients and the right materials, and you have to have the right tools to get the job done. You can still do it, but it's going to be very hard on you. You don't know how it's going to turn out. And then when it does turn out funky, you may not know what the problem was. You may not know why that wall leans when you thought that you had measured it correctly, or you made some assumptions that you shouldn't have made, or you didn't account for the assumptions that were necessary, right? So I like that analogy that the right materials will equal a finished product, but also it's going to equal a finished product that you can trust, that it's going to be valid, it's going to be reliable, it's going to be something you can count on and others can count on to be valid and reliable. And it's really just going to make your statistical analysis a lot more robust and a lot easier, in fact. So I like the fact that you also have to account for, or at least correct, some of that missing data, that having a few missing data points here and there won't necessarily, in a lot of cases, drastically impact your study. But if you don't account for them, you don't recognize them, and you don't see the impact that they could have, then of course you might have some skewed data, and that's going to make statistical analysis difficult, if not very inaccurate. And so to account for those things is very important. And then, of course, screening for outliers. I do like the idea that large unexplained and unexpected numbers in data can happen. And the reason I like that is because I like to think of it as not all outliers are random. Sometimes you have to look at them and wonder not if they're telling of the data that you're being presented with. And so having that conversation in your head, going through statistical analysis and reviewing those outliers to see in what way they might impact your study are really important. It can also be really fun. And then, of course, you've got your assumptions that you have to make. You have to make sure that there's a normal distribution. You have to make sure that there's linearity, that there's a connection between the two. And then your homoscedasticity. I'm not sure I'm ever going to say that correctly, especially without it in front of me. But the idea that your samples and your scatters and everything should be equal and should be easy to interpret, and that you should be able to recognize the way in which not reviewing your data can have a major impact on your study. And so this was a fun one to do, but it was also complex. And so I appreciated your post. Thank you.